Hi, my name is Stephanie Marbella and my teammate is Katie Yee. We are Team 1 from ISTA 431, Data Warehousing and Analytics in the Cloud. We are presenting Practicum 7's assignment, which is about a company called Wild Rides. We also want to present the solution we're offering to address their transportation system problem. Wild Rides is a transportation company that provides people rides to their destinations using unicorns. The problem was that our company did not know how to track the whereabouts of the unicorns. Our company also wanted to monitor the health and status of the unicorn fleet. We equipped each unicorn with a sensor that reports the location and vital signs. Before we define our solution, let us begin with a definition of the cloud and AWS services. What is the cloud? Before the cloud, getting work done was more time-consuming and expensive. Workers had to share computers and travel to the same place. They also had to use individual expensive software to get their tasks done. The cloud is an elastic computer that solved these past issues. Cloud computing was first in use in 1996 and is still in use everywhere today. Cloud computing is a technology, a movement, old ideas in a new form, and a marketing slogan. Public cloud operators are more powerful than a computer and can perform tasks that are too hard or too expensive for a regular computer to perform. The cloud is a very powerful tool that connects many small computers or data centers into one global network. The cloud is accessed over the internet along with the software and databases that run on those servers. The cloud service is a platform that provides multiple services that makes work easier for people who deal with database systems. They have a layered architecture that deals with retrieving, analyzing, and storing data. A cloud can be infrastructure as a service, software as a service, and platform as a service. Users use APIs to gain access to the services. A cloud is a laboratory assistant because we can use the cloud services to be a part of our applications. A cloud has an event processor service where it receives and maintains the events. A cloud is also a programming platform because users can write applications and use the database services in the cloud. Instead of local databases from small applications, users can use a cloud database. What are Amazon Web Services? According to Amazon Web Services, AWS, is the world's most comprehensive and broadly adopted cloud platform, offering over 200 fully featured services from data centers globally. Millions of customers, including the fastest growing startups, largest enterprises, and leading government agencies, are using AWS to lower costs, become more agile, and innovate faster. AWS is a leading cloud platform. So, for the functionality, AWS has significantly more services and more features within these services than any other cloud provider, from infrastructure technologies like compute, storage, and databases to emerging technologies such as machine learning and artificial intelligence, data lakes and analytics, and Internet of Things. This makes it faster, easier, and more cost-effective to move your existing applications to the cloud and build nearly anything you can imagine. AWS also has the deepest functionality within those services. For example, AWS offers the widest variety of databases that are purpose-built for different types of applications, so you can choose the right tool for the job to get the best cost and performance. Now, let us begin describing our solution to Wild Ride's transportation system problem. First, we used AWS Cloud9 IDE to connect to our website and unpack the command line clients. Next, we created an Amazon Kinesis stream and ran the producer in AWS Cloud9 IDE to start emitting sensor data to the stream. The AWS Cloud9 IDE produces messages into the stream. The producer emits a message each second to the stream and prints out a period, which represents ongoing live activity. Linear graphs recording live data begin to form. The put record sum bytes graph begins to record several thousand bytes put per minute. To read messages from the stream, we ran the consumer file in a new terminal in the AWS Cloud9 IDE. It prints live information that shows changes in Shadowfax's status. The Amazon Kinesis stream stores data sent by the producer and provides an interface to allow consumers to process and analyze the data. We created an Amazon Cognito identity pool named Wild Rides to grant unauthorized users live map access to our stream. Then, we gave the unauthorized user IAM role the ability to access the live stream in read-only mode. As you can see in this chart, the Wild Rides Cognito pool shows that unauthorized users can now access the stream. There are two unicorns because each terminal that runs the producer file tracks a new unicorn. This gives unauthorized users the ability to see where Shadowfax and Bucephalus are going. We used Amazon Kinesis to connect the input and output streams together. We used the Data Streams console to create a new stream named Wild Ride Summary. It aggregates sensor data from the unicorn fleet in real time. We made a new analytics SQL application, Legacy, called Wild Rides that connects to the Wild Rides Kinesis stream. The SQL application reads from the Wild Rides Kinesis stream, calculates the total distance traveled and minimum and maximum health, and magic points for each unicorn currently on a Wild Ride. It prints the data into Wild Ride Summary. The SQL application reads from the Wild Rides Kinesis stream, calculates the total distance traveled and minimum and maximum health, and magic points for each unicorn currently on a Wild Ride. It prints the data into Wild Ride Summary. The Wild Rides Summary Kinesis stream application gives a live output of these aggregated statistics to an Amazon Kinesis stream every minute. The more unicorns are added, the more data Wild Rides Summary gives as an output. Since we have two unicorns, we see the current status of both of them. We wanted to process real-time streams over unicorns. We created an Amazon DynamoDB table called Unicorn Sensor Data. We gave it a partition key called name of type string and a sort key called status time of type string. We use the defaults for all other settings. We attach the AWS Lambda Kinesis execution role policy to the role to give the Lambda function the appropriate permissions to read from Amazon Kinesis streams and to log to Amazon CloudWatch logs. We created an IAM role called Wild Ride Stream Processor role for the Lambda function that we will need. We created a Lambda function called Wild Ride Stream Processor that is triggered whenever a new record is available in the Wild Ride stream. It uses the Node.js 14x language and has the Wild Ride Stream Processor role permissions. We created an environment variable with the key, table name, and the value unicorn sensor data. We also configured the function to use the Wild Ride Stream Processor role created in the previous section. To process real-time streams over our unicorns, we used AWS Lambda. We processed data from the Wild Ride Summary Amazon Kinesis stream created earlier. We created and configured the Lambda function to read from the stream and write records to an Amazon DynamoDB table as they arrive. The Lambda function reads from the Kinesis stream of summarized unicorn data and saves each row to DynamoDB. We created an Amazon S3 bucket called Practicum 7 that will be used to archive raw data. Next, we used Amazon Kinesis Data Firehose to archive the raw data to Amazon S3. In the picture, we see how it works. For the ingestion part, we configure our data procedures to send data to Kinesis Data Firehose. For transform, we transform source records using an AWS Lambda function. We can also convert the record formats. For the loading, we deliver data to a specified destination, including Amazon S3, Amazon OpenSearch Service, Amazon Redshift, and various HTTP endpoint destinations. We created an Amazon Kinesis Data Firehouse delivery stream named WildRides that is configured to source data from the WildRides stream. We entered 60 into buffer interval under S3 buffer to set the frequency of S3 deliveries once per minute. It delivers its contents in batches to the S3 bucket. Finally, we used Amazon Athena to run ad hoc queries against the raw data. We created a folder named Athena Query Results Practicum 7 in the Practicum 7 S3 bucket. Amazon Athena queries the raw data in place on Amazon S3 using the JSON serde. While running the producer file in Cloud9, we waited for a while for a table with rows of data to form. It created a CSV file and a metadata file inside the Practicum 7 S3 bucket. Using the AWS Management Console, we navigated to the S3 bucket that we use as our Kinesis Data Firehose delivery target. We verified that Firehose is delivering batch data files to the bucket. We downloaded one of the files and opened it in a text editor to see the contents. We queried the Amazon Athena table to see all records that have been delivered via Kinesis Data Firehose to S3. The data matched the file inside the Practicum 7 S3 bucket. Thanks to the serverless real-time data processing app, our company, WildRides, can now track the status time, latitude, longitude, distance, health points, and magic points. The sensors on the unicorns send the WildRides analytics team the tiny details about each unicorn's condition in the form of a table. The live stream from the sensors updates the table each minute. Since our talented IT team created a functional app for the sensors, our tracking problem had been solved. We no longer have to worry about our unicorns getting lost or becoming sick.